All right, good morning. How's everyone doing? All right, I like that. Thank you, Norm. Awesome. Great. Excellent. Well, I'm very excited to be up here with two folks who know a lot about mobile and to help educate the rest of us. And so to my immediate left, to all of your right, is Cole Crawford. And Cole's had a really interesting career, both being in the private sector, then he went to the public sector, and now he's an entrepreneur. So he's got a very interesting lens. And part of the public sector tour, where you were the founding director of OpenStack, as well as Open Compute. And so that's great. And now you're the CEO and founder of Vapor.io.
Correct.
Excellent. A huge thought leader in data center technologies and edge computing. And then to his immediate left, to all of your right, is Chaitali. And Chaitali has spent her whole career in mobile and has a really unique view. And most recently, currently she's at Qualcomm. And before that, she spent 2.5 years at Reliance Jio. And I don't know if anyone in the room knows anything about Reliance Jio, but I actually think it is the biggest story that nobody in the United States is talking about. Reliance Jio is a mobile company based in India, and the fastest growing mobile company for sure in India, and if not the world, where in less than 6 months, they added 100 million customers. And that's because of the work of Chaitali and her team there. And now she's at Qualcomm helping lead their data center technologies and what's the future for mobile. So really, really excited to have both of you here today. And I thought you both have such a great lens of the mobile industry and what's going on and what does that mean for all of us. But I thought we'd start with where we are today. So what are some trends or things that you're seeing in the marketplace that you didn't see 5 years ago, that weren't at the forefront 5 years ago? And Cole, why don't we start with you?
Sure, yeah, and thanks for having me. Glad to be here. I think what we see, and I'm also ex-telco, US West and Quest Communications, and I think what's really interesting about where we've been versus where we're headed is the combination of data mass, application mass, and data velocity. All of that is speeding up in a much more dynamic internet, and we're seeing. It was funny. I was speaking with one of the big cloud providers, and they were launching a new product, and they said they spent a year doing research on latency for this new type of application they were rolling out, and latency wasn't mentioned by their customers for the first 12 months, and they thought, this has got to be wrong. Why do we not have this here? So they went back, and the customers said, well, we just assumed because if it's in your cloud that we're going to expect 200 milliseconds of latency. It's like the internet hasn't been architected for very low latency applications, but to the points that were being made on the previous panel, machine learning, artificial intelligence, there's an entirely new type of dynamic, low latency internet that is being created, and good for humans, bad for the way the internet's been architected. You can't change the speed of light.
Great. We'll talk about some of the things we're doing to help get close to the speed of light. And Chaitali, what about you? What are some trends that you're seeing in the marketplace from your vantage point that weren't obvious 5 years ago?
Absolutely, and happy to be here. Thank you for the opportunity. So one of the biggest things that we see from the vantage point of where I am right now, in Qualcomm data center technologies, and having seen the evolution of mobile, is really applying some of the lessons from the cloud to telco, right? That's something that I find extremely exciting right now, right? So all of you might have heard about, the whole trend about network function virtualization, right? Fancy name, but what it really is to, again, apply some of those learnings from cloud to telco to see how we can take systems that were really embedded systems. You put up on the tower, you see those big things that are hanging there, but kind of, making it more centralized, more virtualized, putting things on general purpose servers, doing things in sophisticated software, and that's something that is new. I think it has kind of come up really drastically in the last 5 years, and whenever there is something like that, it's an inflection point, and you have new entrants. People who were not really thinking about telco now can write their own virtual network functions and can put it on general purpose software, right? So that's something, and kind of dovetailing into 5G, where we see more bandwidth, address the latency issues that Cole just talked about. Those are things that are new and exciting in our world right now.
It is really exciting. So, you brought up 5G, and so currently we're in a 4G world and testing 5G, and when do you think that standard is going to get finalized?
Okay.
How far away are we from finalizing the 5G standard?
So it's very much on track to get finalized in the next few months, if not this year. But while that is happening, and this is a process we've been through as an industry for 3G, 4G, even before, is as the standards are getting finalized, and it does happen in stages, right? But we are very, very close on 5G. The trials get started. So there is MWC Americas that's running in Moscone, just like as we speak, last 3 days, and you'll see 5G systems up and running. It's all over. There are operators and handset makers and infrastructure vendors who are kind of doing trials already on 5G. So it's very exciting. We are very, very close, and we are looking to see deployment starting to happen, end of next year or 2019. Yeah.
So what Anthony said on the last panel. So the future is here, and it's almost distributed.
Absolutely.
Okay, great. And so once, 4G kind of took 2 years to roll out. So we're close to finalizing the 5G standard. We're going to start to deploy it. How long? Will it take another 2 years for it really to get distributed?
It won't. No. In fact, you saw the news from T-Mobile probably last one. Maybe you didn't, but T-Mobile announced last week that what took them 2 years with 4G, and you got to remember in 4G there was a fight for WiMAX versus LTE. So that's kind of slowed things down from an ETSI and 3GPP standard perspective. But T-Mobile came out last week and said what they did in 24 months a couple years ago, they will roll out in 6 months next year. So you're seeing the speed of innovation speed up.
Any idea why it's going to take so much of the fraction of the time?
I think that what you have is consensus around the ETSI MEC standard in technologies, new technologies in the form of cross-haul and mid-haul. And to Anthony's point around the distribution, if you look at some of these technologies like Google Fi, we love to get up on stage and talk about the nervous system, right? All the brainy things you do with machine learning and artificial intelligence. But for all of that great work, you have the cardiovascular system. Right, you have to think about the heartbeat and the regulation of the body temperature. And if we're building this big decentralized future world, we have to take care of both systems. And I think the telcos, the MNOs, along with the cloud companies, the hyperscale cloud companies, you have Facebook who has built base stations now. They've built 60 gigahertz and 3.5 gigahertz base stations for technology and spectrum, unlicensed spectrum, that allows them to, in India, bypass a lot of licensed spectrum. Billions of dollars of innovation can be saved by innovating. And so I think you have the MNOs saying, here's a threat being led by the biggest companies in the world now. We should probably get to some standard faster and not be out-innovated.
Yeah.
That's
and
great.
Kind of adding to that is, this whole, I would say, industry-wide understanding, and we have had a lot of learning over the years on the need to do things more automated. There's a lot of effort on orchestration, where you had to send a truck to put a new box and fiddle with things. We want to do things more in software, and I think that is something, and again, in the last 5 years, it's really taken root, and that's making things simpler, really more agile, more simple. That's while we get the systems out there.
Definitely, that's great. That's great to hear that we're learning, and competition is
Mm-hmm.
helping it drive innovation for all of us, which is terrific. So you quickly you mentioned the base station. I'd love to talk a little bit about that because again, you both have spent your careers for a long time thinking about the data center technologies. And if you think about a base station today for mobile and where it's going, what's over the horizon, and what are the implications of those changes?
Okay.
Chaitali, why don't you start?
Sure. So I'd like to expand the word base station a little bit, right? It is everything that stands between your mobile, that your iPhones and your Android phones, all the way to the service that you're trying to access, right? You want to send a WhatsApp message, or you want to post on Facebook, or you want to talk to somebody. It's really everything in between, right? The base station, so to speak, the one that you see on the tower, the most visible part, because we are driving by it all the time. And in the 2.5G, 3G timeframe, there were really boxes. Again, like I was mentioning, the embedded systems. You build SoCs, you put a box around it, and you hang it up on the tower. slowly, as that system has become more complex, it has become more disaggregated, right? Now you have radio heads up on the tower, and you have these baseband units either, and Cole, I'm sure you'll talk more about that, either at the base of the tower or in more centralized aggregation point, right? And that is a trend that is continuing, and we see that, right? We hear CRAN, centralized RAN, vRAN, and so on, and then behind the radio network is what's called the packet core, the radio network core, the multimedia subsystem, and the trend really is for all of that to get more centralized, virtualized, but within limits, right? Because as 5G is coming in, and we're going to have things like massive MIMO, which is like multiple antennas, right? Like really large numbers we are talking about. And the processing that you need to do that's close to the edge is increasing. So in that sense, we need to be pragmatic. We just can't say we just put everything on the cloud, right? Because then you're going to really kill the bandwidth, the mid-haul, so to speak, between the tower and the aggregation point. So I think, as anything else, it's an engineering optimization problem that we need to solve, and it's really breaking the base station apart, I would say today, and kind of doing things in a new way.
I just want to add. Telecommunications might be the one industry with more acronym soup than IT. You got massive MIMO, and
Guilty.
We sound really smart, but these are just acronyms, maybe. So what is a base station? A base station is a motherboard, a radio, an antenna, and a network interface card. And we are seeing a decentralization of that. And if you listen to folks like Peter Levine at Andreessen Horowitz, he's saying the edge is going to kill cloud. The edge will not kill cloud. It will augment cloud. But you can get no further to the edge, the true edge, than the radio access network. It is what connects us to the things we want to be connected to with the help of Cloudflare in the internet. And there's, when latency becomes important to you, the true edge is really the meet-me point between the wireless side of the world and the wireline side of the world. And that connection is as real as glass in the ground. The fiber optic information superhighway that gets built between Chicago, east and west, down. We've architected our internet in such a way that it's no different than the airline industry. We take routes and hops, and there are
congestion.
There's congestion. There's QoS. There's lots of things that go into that. The base station, I think what you're going to end up seeing here is a massive virtualization of not just the radio access network, the entire function of the base station today, which you can think of, as Chaitali said, as a big computer that's sitting at the top of the tower, is going to move down and be virtualized into commodity white box, right? Pick your silicon, does not matter, but it will be commoditized, and the baseband unit will be virtualized. The evolved packet core, which you mentioned, will be virtualized, and we will end up in a decentralized world where we're no longer talking specifically about wide area networks, campus area networks, and local area networks, but now you're going to have a metro area network that is far more geographically localized to the data proximity of the relevant data that's being captured, analyzed through all of the wonderful machine learning and artificial intelligence capabilities we're building now.
Feels like with that shift, there's lots of opportunity for new entrants and innovation to come in. And obviously, you've started Vapor. What are some other innovations are you seeing arise because of some of this commoditization out of the base station?
I think I guess the first and foremost is you're seeing a lot of innovation, really actually led by the telcos in the form of SD-WAN and network function virtualization. They do not want to own big, fat, dumb pipes. Right? The idea is to make an intelligent relationship that can be monetized. And it's, you look at technologies like Greengrass and Lambda, these serverless functions. I think you start marrying serverless functions into network functions and being able to charge for things. I think the best thing that happened to the MNOs, I don't know if this is being recorded, but I guess if it is, I'll be recorded saying it.
Well, say it first, and then I'll let you know. No, it is being recorded. It's being live streamed too. So go ahead, Cole.
Hey guys, the FCC and what they're thinking about doing in the form of net neutrality. This is the best thing that could happen to the MNOs. Right? It allows for fast lanes to be created, which is good for business. we'll save the philosophical discussion for when we're not on stage, but it's good for business. And I think you're seeing a lot of innovation happening around the VNFs, the SD-WAN, and what is today considered a big fat dumb pipe, and moving that to an intelligent connection between two things that can be monetized.
Yeah. And kind of talking about innovation, I see a lot of that all the way down to the SoC level, right? We are building different kind of chips that we were building earlier, right? And these need to be more general purpose, but also, different power performance, something that's more suitable to what you can, afford to put or hang up on the towers or at the base of the tower, so to speak, right? Interesting accelerators, including things like machine learning, because that's one of the things that we see that it's going to become really a way of doing things. You learn, you collect the data, you kind of analyze that, and you kind of feed it back, right? So all kinds of accelerators on cryptography, on machine learning, along with general purpose processors that are new and different, right? That meet the higher performance and the right power ratio that you need for telcos. So a lot of new development that I'm seeing on even the silicon level. Right?
That's great. I want to go back to what you said before, Cole, about data and how that's driving what that means in a mobile world. So give us a little bit of context of how the amount of data is increasing exponentially, and what the impact does that mean on the mobile side?
Sure. Yeah, I don't know if you guys have read this book, Ready Player One, but sci-fi book, pretty interesting book. We've been promised this really neat world ahead of us with AR and VR and autonomous driving, and we'll see if machines and algorithms can make moral decisions for humans in the future. Could be a dystopian future. But on the technological side of the delivery of this world, you cannot defeat the speed of light, which means, let's take a look at the human eye. The human eye can see about 150 degrees vertically and about 180 degrees horizontally. And at every degree, you can see about 200 points, which means if you take some very mild compression, still capable of delivering a 4K stream, each human eye is capable of about 5.4 gigabits of data a second. Now, if you're going to get that type of streaming, if you're going to get the type of latency you need to be able to deliver a true augmented reality experience without becoming physically ill, you need a sub-7 millisecond round-trip decision for that. That's a very different type of internet than we have built today. Autonomous cars. I mean, imagine the moral implications of an autonomous passenger in a car driving 60 miles an hour, which covers about a third of a football field every single second. That car needs to make a sub-4 millisecond decision about where to drive that car when this autonomous passenger has no ability to take the steering wheel, and a pedestrian could be illegally walking across the street, where LiDAR, camera, sensors may or may not be able to sense that human. There are technological boundaries that are in front of us today that we're trying to overcome, but that means fundamentally a re-architecture of how we've built out the internet today.
And being more decentralized, and your vote would be that means more decentralized, closer to the eyeballs.
You have to get there. You have to be closer to the radio access network, and that doesn't necessarily mean that everything happens. If you've seen this show Silicon Valley on HBO, it doesn't mean we have this decentralized cell phone cloud, but you do have this wireless mesh capability on the front haul, and you do have cross haul capabilities in the form of allowing service activation to happen within what's called the RSSI. So in the radio signal strength indication, as you move across a city and you have a quick 1 second buffer on your YouTube video, that could be very well you shifting to another tower and getting your signal back. This has to happen, and so the amount of, again, data gravity, data velocity, data proximity, it's a far more dynamic world than what we've experienced to date.
Absolutely.
Mm-hmm. Okay, I have one more question, then I'm going to turn it to the audience. Shifting gears, how has regulation driven development in mobile, and what's on the horizon on a regulation standpoint ahead of us?
Yeah.
Chaitali?
Okay.
Go ahead.
All right. So again, Cole is more of an expert on this area than I am, but just a few things that I've seen. Regulations have a place that's separate from market forces and technological forces. But you usually think about regulatory bodies in our world as the ones that take care of all the spectrum allocation, right? Figure out how the interconnects work, how to protect publics, think about public safety and so on. But the regulation also is, I think, very geography specific, right? Because different areas have different socioeconomic interests, right? So one example that I've seen in India, while I was there a couple of years ago spent some time there, is this question of identity, the user identity, something that we don't really think of in the US and in Europe because, we all know, right, we have that number stamped on top of our head, we know
social
exactly
security number,
social security number and so on. In places like India, that system itself is in progress, right? Anybody who's familiar with the Indian system, there is a voter card, the PAN card, the Aadhaar card, it's really evolving. So what happens is the mobile number becomes your de facto identity. And it has kind of happened organically. It's not like somebody set out to do. Now the regulatory body needs to step in and kind of resolve all that, kind of resolve, your registered mobile number with your national identity. So it's something that's very specific to the geography that only, that regulation or regulatory body can take care of, right? Mm-hmm. And there are similar examples also in the US and other folks.
Sure, yeah, I would say that, if you can legally circumvent regulation, do it. Legally. It's hard to follow the rules when the rules move so slowly. And it's not to say that the government doesn't want to increase their pace of innovation, it's just difficult. And this is why you see unlicensed spectrum like 60 gigahertz for data ingress and egress and CBRS 3.5 gigahertz for telemetry data. You see companies, again, like Facebook and others investing into these base stations where, maybe you're not talking over licensed spectrum, which is, it's federally regulated. You have to, buy that spectrum. But now think about the industrial IoT world or even the regular IoT world. You have Sigfox and LTE-M, and you've got LoRa, and you've got NB-IoT. You've got these all get terminated at base stations, right? In some form or fashion, there is a way to get data to and from something. You will see municipalities in certain states move faster than others, and those will be your first smart cities. So it's a big problem.
Down to the municipality level.
Totally.
It's less of a federal. There's opportunity at the municipality level, less for the federal.
It's weird, this word. State trumps federal, generally.
Are there any questions from the audience? I see a hand right here in the back. We'll go to you first.
Thank you. It's nice to see all these wonderful things happening in the network, but the problem I have is I can't get to network. I live in the flatlands in Palo Alto. Internet cell phone service sucks, and that's a trademark. A technical term, and yesterday I was driving from my house to 280, which is not a long distance. A voice call dropped.
Yep.
So how do we make sure that the cell phone service is reliable, and when I go from cell to cell, that I don't lose the connection?
Yeah, you're going to see a lot of innovation happen around 5G there in the form of small cell, what's called small cell. It used to be that the radio access network was largely terminated at macro cell sites, so these big base stations that have to deal with hills and dark spots, et cetera. But via building tops and lamp posts and other capabilities, you now have small cell, which is one of the de facto standards being built into the 5G standard today. And hopefully that goes away for you. Now, what carrier you're on and how they're investing into small cell technology will affect that. But there's obviously recognition that connectivity needs to be more uniform across dense urban metro areas. And small cell is how that's being happened. And
5G is getting rolled out likely next year, so hopefully this time next year that problem has gone away for you.
And also the tracking of where some of these dark areas are, where there is no coverage, that's getting better. Because a lot of it is, if you know there is a problem, you can do something about it, whether it's with a small cell or increasing the capacity of that macro base station. So that feedback is increasing, and that's hopefully going to make things better for you. Yeah.
I see a question right over here.
Hi, my name's Joe, and I'm with a small VC firm called D&A Partners, and 23 years in mobile wireless for me, USA and Asia. My question comes down to, right now we're in a monopoly of the operating systems, and the consumer doesn't have any choice to be outside of those two ecosystems, iOS and Android. Do you think in the near future, when you were talking about the disparate elements of putting more software on the network, could the consumers get outside at least, or be disintermediated inside of an ecosystem? I hope I'm... So consumer is not tied to an ecosystem and having all their metadata exhaust going to one of two companies.
Here, I guess I'll take a shot at that. And what I'd say is, Arthur C. Clarke, who is obviously a science fiction writer, said, if what I say seems reasonable to you, then I will have failed miserably. But if what I say sounds completely unreasonable, then maybe we'll have a chance at understanding what the future really will be built for. And I would say there's probably some millennial right now, after the bandwidth of 5G, which remember is far lower latency, far higher bandwidth. You've seen these sci-fi shows where the experience of the cell phone gets streamed to you. We're entering a phase of connectivity and broadband and technology that you could stream that to a phone. If you remember roaming profiles, you remember desktop streaming, Sun Microsystems had this actually. We're not that far away from it. Whether that's a Linux-powered thing or a Microsoft-powered thing, or some millennial on Sailfish or WebOS are doing something else, who knows? But what I will say is humans are terrible at the future value propositions of technology. I don't want to guess on the implementation of that, but certainly people are thinking about how to prevent lock-in.
And actually, one example that I'd like to bring up, just recently, I think about 2 months ago, there's a phone that launched in India. I think it's called the Geophone. The idea is to have a 4G phone, but kind of like a feature phone, right? Which is almost like, what are we talking about here? Like, you need that smartphone, you need that access to the App Store. But then, there are certain markets, and hopefully, that will become more prevalent, where, you don't need to have everything on your phone all the time. And that leads to kind of new ecosystems, a new way of thinking, doing more on the cloud and streaming, like like Cole mentioned there, right?
Yeah, I understand that. Here. I'm occupying a little bit of time here. I apologize. But my question, I know that Sailfish is becoming more prevalent in China, Russia, and India, and it's already deployed in India. It's called Yola Sailfish operating system, 100% Linux OS. Yep. But my question was directly towards the network having more software on it. Could it disintermediate the iOS and Android for the consumer? Can you segue or yield it from Apple and Google, your metadata?
I don't know that you'd want that. Maybe you would, but the developer, look how long it took Android to catch up to the developer app ecosystem. I remember being so jealous of Shazam back in 2001 or something. It was not on Android, and it didn't show up on Android for a long time. I feel like the developers are where the gravity happens, and for better or worse, I think we have our two standards for a long time.
All right. Thank you. Please join me in giving them a warm round of applause. Thank you.